For number 16, we are going to determine the horizontal and vertical asymptotes of this rational function. Now, for a horizontal asymptote, we talked about that earlier. For the horizontal asymptote, it's all about the degree of the numerator and the denominator. If the degree of the numerator is less, then it's just going to be y equals 0. If the degrees are equal, then it's going to be a over c, leading coefficients. If the degree of the numerator is greater, then there will be no horizontal asymptote, but maybe there will be a slant asymptote. So which situation are we in? Well, the degree is all about the power of the variable. So this is a plane x and this is a plane x. So that's both degree 1. So since the degrees are the same, that means we're in the situation here where the horizontal asymptote will be a over c, leading coefficients. So I'm talking about 4 over 2 here. Okay, so the horizontal asymptote, okay, which I will call HA for right now, will be y equals 4 over 2 is 2. So y equals 2. So that is my horizontal asymptote. So now the question is, what about the vertical asymptote? Well, vertical asymptotes happen when, where the function is undefined. In other words, the denominator can't be 0. So you find the vertical asymptote by setting the denominator equal to 0. So 2x plus 6 is not allowed to equal 0. Okay, subtracting 6 from both sides gives me that 2x cannot equal negative 6. Dividing by 2 on both sides gives me that x cannot equal negative 3. That's why the vertical asymptote is going to be x equals negative 3. Alright, because it's always going to be the value that would cause the function to be undefined. So that's it. That's how you do that.